All right, so I'm Phil White, Chief Architect, and I'm going to talk just about what's going on under the hood with the replication feature specifically. So I am going to touch a little bit on Scribe. It's not as much detail as we went over with the storage field base, so if anyone has wants to know any more details, I would suggest watching that video. But just getting into replication initially, again, simplicity being the most important thing for us. That's kind of our primary design goal. You saw in the UI, it's basically a single click to replicate a VM across the other side once you have the cluster connection established. Secondly, security. I'll talk a little bit about that. But essentially, what we're doing is, when those clusters authenticate, we create a secure SSH tunnel, do a key exchange at that time, and then the two clusters can communicate securely. And lastly, efficient failover and failback. And there's been a lot of questions about that so far, and I'll talk in detail about how that lineage is determined and how we can sort of shortcut sending all that data by doing some intelligent cloning. So first of all, these clusters had already been set up, so we didn't see that. But essentially, when you're creating this remote cluster connection to initially do replication, it's pretty trivial. Literally, just point one cluster at one node in the other cluster. Just give it the IP address or the host name, and then your username and password that you use on the web UI. And from there, everything else happens behind the scenes. We do a key exchange, generate SSH keys on both sides, and those keys are then used from that point on. Anytime the clusters need to talk to each other to do a replication, that tunnel gets established on demand, and the data can flow that way.
Are you just doing the storage, or are you doing like configuration, metadata?
We do all the configuration and metadata and everything, and I'll cover that in just a moment. So again, you saw in the UI, it's super simple. Just the setup replication button. Once you hit that on a VM, it asks you which target, shows you the different clusters you've configured as targets, and then you can choose to replicate it with basically one click. Currently, we replicate all of the VM snapshots, so any automated snapshots and snapshots that a user takes will end up on the remote side. And essentially, right now, we're doing a 5-minute automated snapshot if you have replication set up. We are going to support per VM scheduling as well later this year.
So this is basically asynchronous replication?
Yes. Yeah. Yes. Okay. Asynchronous replication. And then once that's established, you can see the progress bar shows up now. It'll show you how much data it's transmitting for a particular snapshot, and you can watch as that completes, just to give you some feedback on that. And then, again, talking about VM snapshots, to answer your question, it was, yes, we snapshot the configuration, the number of CPUs, the amount of RAM that you've configured for the virtual machine, any net interfaces you've configured, the MAC addresses get replicated as well. And then virtual disks, all of the virtual disks that you've configured. And so as you change these sorts of things, they get stored in that snapshot, so that if you restore the virtual machine from a particular snapshot, you're getting not just the storage, but you're getting the exact VM what state it was in at that moment the snapshot was taken. Yeah, essentially that's what I just covered. So VM snapshots, and I'm going to get a little bit into Scribe now and talk about how Scribe is providing this data. But you can see at each snapshot essentially what the diff size actually is, which gives you some feedback as to if you're looking to free up space, which one you can delete, which one to clone, and that's essentially an aggregate of all of the virtual disks for a particular virtual machine. So even if you had 4 disks connected to a VM, that's going to sum total the diff and show it to you for that particular snapshot.
So with snapshot maintenance, I know some other storage platforms have issues with which one you delete or clone or move around. So am I pretty much free to do whatever I like with delete? I can delete anywhere in the tree.
You can.
Take 700 years to rebuild.
It does not take 700 years to rebuild. You may, if you delete the initial snapshot, there are some situations where if you clone, and actually there's a graph I have that kind of would demonstrate this pretty well, but if you make a clone of a VM, there's an initial snapshot that's taken that if that snapshot is deleted, you'll sort of lose that lineage back where you'll have to then essentially copy the entire virtual machine. So I'll answer your question a lot better when I get to that slide, but you'll be able to see how that link takes place. So getting more into Scribe. Just to give kind of a brief overview of Scribe, this was built from scratch for virtualization. We targeted QEMU, KVM, and as a result, we've ended up with a storage engine that is very, very highly targeted at KVM. And you look at we essentially started by looking at the storage API and the native drivers in KVM and say, okay, that's what we're going to target. We're going to build the best system we can to target that exact API. And as a result, we have seamless integration, we call it. I mean, all of the the command line tools, if you were to use them, I mean, you can convert images back and forth from Scribe to QCOW. It's just essentially a supported device type now on our systems for QEMU, which makes things like import and export very easy to do. We can import a QCOW to native straight into Scribe with existing tools. I mean, so it's pretty nice. And this is what we call, the quote-unquote hypervisor level storage. This is not running in a virtual machine or anything like that. This is actually, a native supported device type for QEMU, KVM. So there's no VM in the data path. The guests can use just the off-the-shelf VirtIO drivers that you would normally use with KVM, and there's no storage protocols to configure. So this is kind of an architectural slide that kind of shows how everything relates. Think of this as being one node. So you'll have these processes that are running in the blue boxes at the top. So you'll have a process running for every virtual machine running on the node, and then additionally we have a Scribe process that runs. ScaleD on the left there is kind of our management process that is what is collecting all the data about probably thousands of different conditions on the node and making choices of how to sort of remedy situations as they arrive, when drives fail, those sorts of things. That's another topic that's actually covered in detail in one of the Storage Field Day 5 presentations. So any more information you want on that, I would recommend watching that video because we cover that in quite a bit of detail. The Scribe daemon is essentially what is then providing these virtual, we call them VSDs, virtual storage devices, to the VMs. And the key thing here is that Scribe is actually not even in the data path itself. I mean, we've created what we call a shared memory data path, where these the QEMU virtual machines actually just share a memory buffer with Scribe. So Scribe is able to schedule the I/O from these buffers directly on the raw devices at the bottom. So the RSDs, or real devices we call them. Essentially, we use the stock kernel and the Linux native AIO interface to schedule those I/Os directly on the devices. So
actively shared model or shared nothing type of approach?
It is shared nothing. Yeah. So the only time the data would get copied is, obviously sending it to the network. You have to send it to the second node, essentially, to create, like if you've configured a virtual storage device for 2 replicas or 3 replicas, that has to be copied to different nodes.
Is there a main replica approach that you're going to? Like by default, how many?
By default, we just have two replicas by default.
So 2 replicas meaning 3 total copies?
2 total. 2 total,
okay.
Yeah.
So 1 replica?
1 replica, yeah. Yep.
So how does this work across boxes, across nodes? Because obviously you can have a VM running on node 2 with its storage on node A. Mm-hmm. Is there some data locality, or does the data move to where the node is, or
have a local metadata reference table that refers to it as a hash or something?
Yeah.
Right, so the metadata gets cached locally, and what happens is the data itself is just striped across essentially the whole cluster, right? And we have what we call a placement spec, which is configurable per virtual device. So you can choose to place data based on a number of different things. As of right now, we don't expose that to the user. We just have a default placement spec that is, stripe the data everywhere.
Stripe
essentially.
sizes, what's the
right. The placement spec can be configured to do all those sorts of things. You can look at, how full is the disk, how fast is the disk, how much I/O is it seeing right now, right? Should we reduce hotspots, those sorts of things.
And you've got your kind of QoS-ish data migration movement strategy in order to move hotter data to a faster tier.
Right. Later this year, with when we introduce tiering, that's exactly what we're going to be.
Is that sort of continually monitoring things? Say, if you're seeing a particular hard drive is being swamped,
right.
You may move stuff somewhere else.
You would want to move that onto SSD or something. And,
not even SSD, but just maybe balance out the reads or writes from a particular drive.
Yeah. Okay. And that can be done at a per block level, right? Okay, so you don't even have to move an entire
How does
disk.
the interface, because obviously the shared memory data path can't work across nodes, so...
No, it does not. But in a particular case, like say you're doing a read, right? You don't have to copy that data. If the data is local, we're essentially scheduling that I/O in the kernel. It fills the buffer. That's the buffer that is in use by the VM.
As far as the metadata of what sits on disk, is that sitting inside of memory? Is it sitting inside a local cache table?
It's cached in memory. It's on the same disks, on the same RSDs, but when that virtual device is mounted, we load that data into a cache, and
So when the data reference comes, it'll find that this chunk of data exists in these 16 blocks that exist across these 8 nodes in the cluster.
Exactly.
And
that metadata is in RAM. So it's written obviously when it's updated. If the data has to move,
anyway, so it's just
exactly. It's a small table. Yeah, it's like 8 megabytes per terabyte, I think.
And you'd preferably want to stripe over as many disks as possible to get for performance.
Exactly. Yeah, so you can see high IOPS numbers when you have that data striped like that, depending on your workload, obviously. But it's.
So when you say that, and I have to ask we go back to the old school days of NetApp and maybe even current school days. We're 80% consumed on disk, right? We're spread and spanned across everything, and then I lose a node. I walk over there, I decide to unplug a node because I'm a bastard. What is going to be the impact upon operational rebuilds or access to that data because we only have is it intelligently saying I will not have the same block of data present within the same shared nothing architecture within the same node, so that way I at least have a separate copy that exists elsewhere.
Right, so essentially each RSD has a sort of a failure identifier, failure group identifier, right? And so you can set up, by default, all 4 drives in a node are on a one failure group, and each node is in a different failure group. But you could even go into more detail than that and saying, okay, well, I have 6 nodes, 3 of them are on this power system, the other 3 are in this other power system, so that way you're guaranteed if you lose one particular power system, you've got all your data on the other 3 nodes.
So I lose, let's say I lost half the nodes, and this is a very specific context, right? I lose half the nodes, they go down, it starts doing a rebuild, starts making my data accessible, and those other ones, it was just a power trip.
Right.
10, 15 minutes later, they come back online. Does it turn off, say, don't try and access and use those blocks. Those are no longer valid as part of the master metadata table. Maybe there was an election that says, you guys need to join into our family now instead of
Absolutely, yeah. The whole system is backed by Paxos. I don't know if you're familiar with the Paxos protocol, but essentially we're doing, the root metadata for any particular VSD, you need to get quorum to update that root metadata. So you're always guaranteed, a full consistent VSD image.
With Paxos, you're actually making the choice to be consistent, because I know Paxos can be eventually consistent.
Right. So in CAP theorem, this is a CP system. It enforces consistency and partition tolerance at the cost of availability. Right. Where if you lose all the copies of your data, you have to go offline. Right.
Is there a timing point for the consistency point generation around this? Like, how often is it actually operating in the CP model?
So Paxos only comes into play if you're updating the root metadata. So that's a pretty rare operation because it's very expensive to use Paxos. I mean, there's a lot of communication that has to happen in between nodes. So that's reserved for, you've got a failure scenario. Your metadata is now, one of your replicas of your metadata is offline. We have to update that metadata, and so it's sort of like, you can imagine these failures just kind of all come together to, okay, now we need to update the root metadata because we moved the metadata, right? So that's the one time we'll actually fall back to Paxos to say, okay, we need to actually get consensus that says, yes, we've moved the root metadata for this VSD to a different location. And
is there a quasi kind of thing that will prioritize serving VMs rather than doing the rebuild?
Right now, no, and we don't automatically rebuild immediately on node failure. That's drive failures. Certainly, we do. We immediately start restriping that data.
So node failure maybe for 10 minutes, and when it comes back up, you want to catch up rather than rebuild a whole node.
So what happens is, if there's a node failure, you've lost some blocks of data. Anytime one of those blocks of data is written to, we immediately recover that one block of data. So we're going to re-replicate. We're always going to make sure we're writing all replicas of any block of data that gets a write. So if you have a lot of writes coming in, while that node is down, any block that was on that node that's getting a write, that block will be immediately relocated to 2 of the nodes that are up.
With another replica? Or?
Yes. So, well, if there's still a replica available, that might not move, but. And depending on how your failure groups were set up, there might be different situations that happen.
So if a node has failed, comes back, is there a time window until you realize the node's gone permanently down?
Right now, that's a manual process. You need to kick off a recovery if you decide, okay, this node has been exploded in the rack or something.
Another very kind of semi-specific failure scenario, just curious, right? The node's up, my perp fails, and all the disks are offline, but I still have compute, and I can still serve up virtual machine access to disks, or because across the other disks.
Yep.
But what's the implication of failure? Does it take that node offline because storage is offline?
No, it does not. So any particular I/O that would hit those disks, it realizes that in that moment and will write somewhere else. The state machines in ScaleD would recognize that kind of failure anyway, and that would probably be seen as a drive failure, as like 4 drives just failed.
Would the VMs go offline, or would they use their other replica copies?
They would always use any replica that's available, even if like a read fails. Same thing, right?
Sure.
We tried to read the local replica, and that block, for whatever reason, is bad on the disk, falls over to the remote replica, right, and pulls the data in that way.
As this matures, are you thinking about moving to like erasure coding for distributing?
Yes. Great question, actually. And the VSD, the way that Scribe is architected is such that you can do that, right? You can have different, what we call VSD drivers in place, and they can run side by side.
Cool.
I think, perfect segue. So we've got, two disks in this first QEMU guest here, and those could be completely separate VSD implementations. You could have an erasure code VSD running right next to just a plain old mirror. Depending on what your use case is for your data and what requirements you want, you might have a VSD that only has one copy of the data. If it was just a scratch disk or something that you want it to be fast, or extra copies, if you want extra resiliency there. So. Because of that, it's just very flexible. It lets you set up multiple disks using whatever requirements you want. So
that's really cool. You could even span it out to the cloud. Like just have a VSD layer that goes to the cloud or whatever.
So sort of getting back into the snapshots and kind of the relationship between a VM snapshot and a VSD snapshot. I mean, when we take a snapshot of a VM, and again, this is integrated straight into QEMU. We use libvirt, which is kind of an off-the-shelf virtualization management library internally. When that API call gets made to snapshot a particular VM, we are simultaneously snapshotting all of the VSDs that are attached to that VM, so that we get a consistent state of all disks that are connected to that VM. And at the same time, we write the configuration of the VM at the particular instant into the same snapshot.
So is there a hook in for Windows to be able to use VSS snapshots?
That will be supported soon. We don't yet do that right now. We just end up with crash consistent.
Will there be a scale computing tools or something that you need to install inside, or?
It won't be particular to scale computing, because it will just, actually it should work today, actually, if you use like the standard, the QEMU VSS provider, yeah. So, but I don't think we've even tested that yet, and that's why we don't support it yet. But that's the idea. That's basically where we're heading with this. So,
okay.
Yeah. So what you end up with on the target as well. And so under the hood, Scribe is essentially copying all those snapshots from the VSDs from one cluster to the other. The VM that you end up with on the other side is really just kind of a placeholder for the VM at the moment. It shows you all of the snapshots you have taken, and any one of those snapshots can instantly be cloned then into a full functioning VM in a failure scenario. So you just pick your latest snapshot, click clone, and you get a VM in seconds ready to run. So this is kind of that Justin, I mentioned the graph with sort of showing that relationship between snapshots and things. So typical example, you create we'll call it gold master VM on the primary site. We set up replication to the remote site. All of that data at that point has to get copied, obviously, because there's nothing on the DR site yet. Make some changes to it. The snapshots will show up on the remote site automatically. Scribe is going to be sending those block differences from snapshot to snapshot under the hood. And at some point we clone it to a second VM, and we want to set that VM to replicate as well. So what's going to happen here is, on the DR site, Scribe is going to recognize that VM B was cloned from A snapshot 2, and it realizes that we already have A prime snapshot 2 on the remote side, so we just immediately clone, and that second VM was replicated instantly, is the effect that you have. make some more changes on B, and at some point we might have cloned another VM C. Same thing. When I go to replicate C to the remote side, it sort of determines that lineage, and will send that clone that particular VSD.
Do you really want to be? You really want to be creating templates and cloning VMs rather than creating them separately?
Yeah, if you create them separately, there's going to be more overhead. Yeah, that first copy is going to.
So this is kind of like a math equation. What happens on one side always happens on the other?
Yes.
At all times?
Yeah. I mean, you can go in and manually break that, though, right? I mean, you could go in and start deleting things on the remote side, and then you won't be able to, like if we deleted our gold master, turned off the replication, I mean, this isn't going to work, right? Because we've deleted that data. But yeah, that's essentially what you have to do. Yeah, whatever happens on the primary site happens on the DR site. Those snapshots that get taken on the primary site will show up on the DR site.
So back to what you were saying, Christopher, before, this is a good reason to go and spend the time to create that golden image and stuff. Yeah. Because if you knew you were going to do replication,
it'll save you a lot of
for every operating system you might deploy.
And use it, yeah.
Yeah, the first time you do one, create a gold image and then use that if you know that you're going to be replicating, yeah.
Right. So in the case your primary site goes offline and you need to fire up these VMs on the DR site, what you can then do is instantly clone those into full-blown VMs. We'll call them D and E. And they start running. They make some changes. Databases are being updated. Whatever's happening, you're writing those things. And at some point, we want to have the primary site. The primary site comes back up. We want to move those VMs with the new changes back. So that's important. You want that to happen fast. You don't want to have to wait for the entire VM to copy. So same thing. When we replicate those snapshots back to the primary site, the same algorithm is used to determine the original lineage of what happened here, and it's able to determine that, okay, the best course of action to get VMD back on the primary site would be to first clone the third snapshot on VMB. And that happens instantly, right? So you've got most of the data back, assuming, depending on the workload, of course, and we only have to move that difference from VMD snapshot 1 to 2. That's all you're transferring back to the primary site, and then you're immediately able to clone that thing back into a running VM on your primary site.
Is that a journal, or how does
pretty amazing?
How does it track that?
That's cool. In the VSD metadata tracks essentially which blocks have changed, snapshot to snapshot. So we immediately know, okay, we're going from snapshot 1 to 2. We know which blocks changed, and we can just transfer those blocks only. So
now, do the VMs on the DR side, when primary site fails, do they turn on automatically, or is that a manual process?
It's currently a manual process. One of the things we have planned for the product is more automation around that, and being able to, either just click one button and having everything happen automatically. Same with Failback. If you want to fail back, click a button and have it just...
Is that because of syncing things up? You don't want it to power up at the wrong time?
Yeah, I mean, there are, obviously you'll have inter-VM dependencies, like you want your AD servers to come up first, those sorts of things, right? So there's some additional things that need to be built.
Network link goes down between the two sites. And
I'm sorry?
A network link goes down between the two sites. You don't want the DR to think...
Right, exactly.
Exactly.
Yeah. So there's some tricks to automating it, but that's all.
Easy, yeah.
Is this a fairly unique thing out there? I don't know. I can't think of many storage replication things that catch up as simply as this, or
I don't know of any either.
So.
It's something that we built, and it's
Sorry,
I don't know if you guys know of any.
I mean, that's
No idea.
what always differentiates us.
I know what we do. I don't know what everybody else is doing. That's Demo. He takes care of all competitive analysis.
So once you've failed back, does it automatically set up the replication relationship again, or have I got to go and say it does?
It does, yeah. So these sites, if you go on the DR site and you look at any of these VMs, when you replicate it back, I mean, the primary cluster is already there as your option to that's where you want to send it, right? It's those sorts of things, those relationships are already established for you. Cool. So yeah. So that's most of the detail I have on the replication stuff. So if you want to get to see how the demo is looking, I don't know.
And this is all per VM as well. Obviously, VMA could still run on A. You could fail over VMB to the once
right.
and bring
Well,
it back.
it's also it
Not
comes
the
in
whole
handy for
cluster.
testing your DR strategy
Yeah.
too, right? You know, so you can basically you got your AD server replicated over to the remote site. Well, hell, you can just fire the thing up, make sure everything comes up right. Yep, just tested my DR. Now I can just shut the VM down, blow it away, and but it's a way to effectively test that as well. So
yeah.